In this WeDo video, we have rhenium, and let's see, they tell us the average atomic mass is 186.21 AMU. They give us two common isotopes, rhenium 185 and rhenium 187, and their atomic masses, and they want us to use the information to calculate the percent abundance of each of them. So we're actually looking for percent abundance. Now remember, this is relative abundance here. So I think what I'm going to do is I'm going to go ahead and calculate relative abundance and then just change it to a percent. Thinking about this, the average atomic mass we're given, so we're given 186.21 AMU. What we don't have is we don't have relative abundance. So we know for one of the isotopes, we're going to say the relative abundance is X, and the mass is, we'll do rhenium 185. So 184.95 AMU. And we're going to add that to the second relative abundance. Now, we're just going to call this Y. But that mass for rhenium 187 is 186.96 AMU. All right, so now we have to make a connection between X and Y, and relative abundance, our relative abundances should add up to 1. So X plus Y should equal 1. So let's substitute, I guess, so we don't have two different variables here. We're going to say that Y, therefore, let's see, Y is going to be equal to 1 minus X. And then we are going to substitute this right into that expression. So that gives us, I'm actually going to write this down here, that's going to give us 186.21. We're going to set that equal to X times 184.95 plus 1 minus X times 186.96. And this just becomes a exercise in algebra. I'm going to go ahead and just write this whole thing out just in case you make any algebraic mistakes. You can kind of check where that mistake was. It's going to be 186.21 is equal to 184.95x. We have to distribute the second part. That's going to be 186.96 minus 186.96x, which gives us 186.21. We're going to combine like terms. Let's see, negative 2.01x plus 186.96. Then I'm going to subtract 186.96 from each side, and that's going to give us negative 0.75 equals negative 2.01x. Solving for x equals 0.373. Now, in percent, that is going to be approximately 37.3%. Now, we have to go back to our work and figure out, okay, X was which isotope? And if you remember, we said rhenium 185, we set its relative abundance equal to X. So that's going to be 37.7% of that particular isotope, so rhenium 185. Now they're asking us to calculate the percent abundance of each of those isotopes. If you remember, these percent abundances should add up to 100. So if we take 37.73, I'm going to actually write this up here. So 100 minus 37.3, we get the relative abundance of rhenium 187, to be 62.7%. So that means I have 62.7% of the other isotope. Since we only have two, their percent abundances should add up to 100. And that is it.